You know, when a newborn takes its very first breath, we all think, wow, that's the hardest thing they'll ever have to do. But what if I told you we were wrong? The real challenge, the most dangerous job a newborn faces, happens completely silently deep inside their tiny body. Today, we're going to dive into that hidden drama and the amazing little organs at the heart of it all, the kidneys. So, here's our roadmap. We'll start by meeting this unsung hero and see what it's like for it to learn on the job in those first critical weeks. Then we'll look at what happens when that delicate balance gets thrown way off, leading to a crisis we call acute kidney injury. We'll also explore the incredible miniature tech that saves these tiny lives. And finally, we'll see why this early fight can have consequences that last a lifetime.
All right, let's jump right in. Part 1, a newborn's unsung hero. We're about to pull back the curtain on a hidden challenge that, honestly, most people have never even thought about.
So let me ask you this. When a baby first enters the world, what do you think is the single most difficult task they have to pull off?
The obvious answer is learning to breathe, right? I mean, that first gasp of air is a massive change from life inside the womb. That's gotta be it.
Or, hey, what about learning to eat? Suddenly having to coordinate sucking, swallowing, and digesting all at once? That's a huge undertaking for sure.
Well, the real answer is a job nobody sees. The absolute hardest thing a newborn does is become its own life support system. The second that umbilical cord is cut, all the support from the placenta vanishes. Instantly, 2 kidneys, each about the size of a bean, are in charge of mastering the body's entire internal chemistry. It is literally like a rookie pilot being handed the controls of a jumbo jet in midair. The responsibility is just massive, and it's immediate.
Which leads us perfectly into our next section. Because this isn't just a tough job, it's a job being done by an organ that's still learning the ropes. We're looking at the first weeks of work, and you're about to see why a newborn's kidney is nothing like a tiny adult one. So the first thing you have to understand is that not all newborn kidneys are created equal. A full-term baby, they're born with about 1 million tiny filters called nephrons. That's their full set for life. But a premature baby, their kidneys are still under construction. They have fewer filters, they're less mature. It's like asking them to run a chemical marathon when they haven't even finished building their legs. This vulnerability, right here, is the key to our whole story. Okay, now this is really cool. This graph lets us literally watch the kidneys learn in real time. The lines represent serum creatinine. You can think of that as the waste or the exhaust from the body's daily work. At birth, that level is high because it reflects the mother's system. But just watch how those lines drop over the first month. That is the visual proof. The newborn's kidneys are firing up, getting better and better at cleaning the blood every single day. So, the kidneys are learning fast, but this is a high-wire act with absolutely no safety net. And that brings us to part 3, when the balance is off. We're about to see just how quickly this incredibly delicate system can tip over into the danger zone. Just think of the kidneys as the ultimate managers of the body's internal world. They are constantly fine-tuning the levels of water, critical things like sodium and potassium, calcium, and even the body's overall acid-base balance. For a fragile newborn, even a tiny miscalculation in any one of these can have incredibly serious consequences. So how do doctors even begin to figure out what's wrong when this balance is off? Well, it can be like solving a complex puzzle, and this shows their brilliant starting point. Often they start with a simple test, measuring the chloride in the baby's urine. If it's low, that might point to a straightforward issue like dehydration. But if it's high, that sends them down a totally different road, looking for more complex problems. It's an amazing example of how one small clue can crack a huge medical mystery. And when that medical mystery points to the worst-case scenario, it has a name. This brings us to the central crisis of our story in Section 4, acute kidney injury. So what exactly is acute kidney injury, or AKI? Well, to put it simply, it's a sudden, catastrophic system failure. The kidneys just stop working. Waste products start to build up, fluids back up, and that whole chemical balance we just talked about is thrown into total chaos. It's a full-blown emergency. And doctors don't just say, "Yup, the kidneys have failed." They have a very precise system for grading just how bad it is. They track 2 key things: the rise of that waste product, creatinine, and the drop in how much urine the baby's producing. You can see how the stages get more serious. Stage 1 is a huge warning sign. By the time a baby is in stage 3, it is a critical, life-threatening emergency. And make no mistake, the stakes here are life and death. This chart is, well, it's sobering. For a sick but full-term newborn, AKI can be fatal up to 18% of the time. But look what happens to babies who suffer from a lack of oxygen at birth, called asphyxia.
For them, if they get AKI, the mortality rate jumps to a staggering 71%. It is an absolutely devastating complication. But even in the face of those staggering numbers, there is hope. And that brings us from the problem to the solution in Section 5, life-saving dialysis. This is a story of incredible miniature technology built for the most miniature patients imaginable. We're talking about patients who sometimes weigh less than 1 kilogram. That's about 2 pounds. Just let that sink in for a moment. Less than a bag of sugar. So the question is, how in the world do you perform a procedure as complex and delicate as dialysis on a patient that tiny? The scale of the challenge is it's almost unimaginable. Well, doctors have two main tools in their toolbox. The first one is pretty amazing. It's called peritoneal dialysis, or PD. It cleverly uses the lining of the baby's own belly as a natural filter. It's a gentler approach. Then you have the high-tech powerhouse, continuous renal replacement therapy, or CRRT. This is an external machine that acts as a tiny, super precise artificial kidney. It's more powerful, but it's also way more complex. And this field is moving so fast. It's incredible to think that it was only in 2020 that the FDA approved the very first dialysis machine built from the ground up just for these tiny patients. This wasn't just shrinking adult tech. It was a total redesign, a revolution in care for the most vulnerable babies. And that brings us to our final section, the future of neonatal care. And we're calling this the long shadow of AKI for a reason, because just surviving the crisis is only the first step. This is why this all matters so much long-term. An episode of AKI can cast a shadow over a person's entire life. This flowchart shows you the chain reaction perfectly. Being born prematurely can mean you're born with fewer kidney filters. That increases your risk for AKI. And surviving AKI as a newborn increases your risk of developing chronic kidney disease as an adult. The battle that's won in the NICU can set the stage for another health challenge decades down the road. Which leaves us with the ultimate question. The technology we have now to pull these babies back from the brink is nothing short of miraculous. But the next frontier, the next big challenge, isn't just rescue, it's prevention. How do we protect these developing kidneys from the very start? How do we make sure that their hardest job doesn't leave a shadow they have to live with forever?